All right. I figured it would be easier if I just recorded something rather than trying to fit it into the chat box. So, what we're talking about here is bicycle rings, right? And the big thing to know about bicycle rings is that they follow a naming scheme that's pretty particular. But once you kind of get the hang of it, it's simple and easy to use. So here we have your compound, and I'm just gonna copy this, give her some copies so that way I can work with those later. But what we are going to be talking about is the naming scheme. So the big part about the naming scheme is that we have this bicyclo box X, Y, Z portion in the middle, right? And what's important to know about bicyclo is that we are going to be naming parts. And I'm just going to move that over. So, of course, we have the prefix of all the substituents and everything like that. Like that hasn't changed. And what comes after the bicyclo is the total. And we'll talk about that in a second. The other big thing to know is that X is always given before Y, which is given before Z. And this is based on size. So, if the ring size is 8, then that would go first. If, the next one was 2 and 1. So with that in mind, we can put nice yellow circles right on our bridge heads. And we always want to make sure that we're starting at the bridge heads. So in terms of numbering, we're going to be putting 1, 2, 3, 4 for the bigger side. And we're going to put 1, 2, 3 for the smaller side. So based on our middle part here, we have bicyclo, and then some number, and then bracket again, right? And so remember that these are always put in order of uh, largest to smallest. So here, this is a larger ring size, so this is going to be X. This is going to be the smaller ring size, so it's going to be Z, or Y, I mean. What am I doing? And then this bridge in between is going to be labeled Z. Okay. Why? Because it's 4, 3, and then 0. So we have 4, 3, and 0. Now, next, we want to make sure that we're doing the total at the end. And the total is equal to x plus y plus z plus 2. And so in this case, it's going to be 4 plus 3 is 7. 7 plus 0 is still 7. And then 7 plus 2 gives us 9, which would be nonane. Now, the reason why is it 2? It's because through this naming scheme, if we just added the numbers, we'd be forgetting the bridgehead carbons. So we want to make sure that we're including those in, which is why we add 2, right? So that's often something I find students forgetting a lot is they forget to add that too. And then all we're going to do is we need to figure out, well, where is this methyl group going to go and how are we going to label it? So for that, once again, we're going to put nice big dots on our substituent, on our bridgehead carbons, I mean. And the rule is we always have to number around the bigger ring size first. No ifs, ands, or buts. So we can, the other part of this too is that we also have to start on a bridgehead. We can't just start, somewhere within the ring. Now, you might be wondering, well, we didn't do that here. Well, we're not numbering for naming here. We're numbering for size. So it's a little bit different. Here, we're numbering for naming. So either we're going to put 1 here and count this way 3, 4, 5, 6, 7, 8. Or we're going to put 1 here and again count 1, 2. Let me do this in a different color, shall we? 1, 2, 3, 4, 5, 6, 7, 8. Oh, would you look at that? We have the same numbering scheme, so we know that this is going to be 8 methyl. Okay, so big takeaways. One is that this bicyclo shows us that the X side is bigger than Y, which is bigger than Z. Adding them together plus 2 gives us the total, and that we always have to start on a bridgehead and number around the bigger size first, no matter what. Now, I thought that I would give you a couple of extra examples just so you have them. In case if you ever have questions, you can at least reference these. So let me draw them all out first, and then if you want to pause the video and try to name them first, you can. Um, feel free. So we have that one, and we have that one. Um, and we're going to put methyl groups there and there. And finally, the last one that I wanted to give you was something like something like that. All right, so feel free to pause the video if you need to, but we're just going to get stuck in on naming these. So for this one down here, of course, what we're going to do is we're going to identify where the bridgehead is. So quite clearly we can see, oh, this is where it is right there. Okay. And then what we're going to do is we're going to number each side, 1, 2, 3, 4. So we have 4, and we have 1, 2. So we have 2 versus 4, and how many carbons are within this bridgehead that I'm just going to redraw because it's poorly drawn. And the answer is 0. So we have 4, 2, 0. So already I can fill this in and say bicyclo 4.2.0. All right. And just like always, I can come up with what the total is going to be by adding these together. And I can say 4 plus 2 is 6, plus 0 is still 6, and then plus 2 gives us 8. So this is going to be octane. And if I wanted to count, I could. I could go 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8 octane. And just to give us another one so we can do some counting on, is what we notice is that we're going to be starting at either the top or the bottom bridgehead and counting around. So if we start at the top one, what we notice is that we get 1, 2, 3, 4, 5, 6, 7, 8. And if we start at the bottom one, what do we notice? Oops. We get 1, 2, 3, 4, 5, 6, 7, 8. And so the question becomes, well, which naming scheme are we going to use? Are we going to be going around this way, or are we going to be going around this way? And so the answer is we're going to be using the green pathway. And the reason why we're going to be doing that is because we want to put the group, even though that, so you might be saying to yourself, well, why isn't this oxygen taking priority? Why aren't we numbering this first? Remember, the rule of numbering the largest side still reigns supreme, even though the oxygen might be the highest priority group. So because it is the highest priority group, we want to make sure that it gets on the lowest number possible that we can give it of the two possible naming schemes. So we're going to be choosing the green pathway. And so this is going to be 8 methyl. And then, of course, too, that just because it's, on the smaller side doesn't mean that we can't modify what the ending is going to be. And so this will be octan, because it's still an alkane, 7 ol. Okay. So nothing about that has changed what is going on. This is still a high priority group, even though we don't name it, name that ring size first. Hopefully that makes sense. Going on to the next one. I'm going to have to put this on a new page. What we have going on is, once again, we have some sort of bicycle group. And we see that this is 1, 2, 3, 4, and this is 1, 2. So we have 2 versus 4 versus 0 once again. And so this is bicyclo 4.2.0. And we can add these together and we get, 4 plus 2 is 6, plus 0 is still 6, plus 2 gives us 8. So we're talking about octane still. And we can go through and we can say, okay, well, which numbering scheme are we going to use? And I think it's pretty obvious that we know we have to count the larger size first. So we're going to be counting towards the methyl group. Because if we try to use the other numbering scheme, it'll give us this sort of larger number for the methyl. But wait, I hear you say, wouldn't that put the alkene on a higher number? What is pink? 6, 7, 8. No, it doesn't. Okay. Even if it did, it would not matter. Okay, because we're numbering the larger side first. So if all we care only about what the numbers are going to be on the larger side, and then everything else that comes on the smaller side is just extra. Okay. That's all we care about. So in this case, it would be 2-methyl. And then once again, because we're modifying this ending, what we can say is that it's going to be not ane anymore. It's going to be ene for an alkene. And we can say that it's 7-ene. Okay. Oct 7-ene. Going on to the next one. Oops. Come on, scroll up. It didn't copy for me. Wasn't that nice? There we go. Oh, you gotta be kidding me. That's all right. I think I remember what it looks like. Kind of looks like Pac-Man taking a bite of something. All right. Hopefully I'm going to draw it correctly. If not, I apologize. And I believe I had that going on. Gonna check one last time. Yeah, there we go. All right. So we have this compound going on. Oh, look, now I can copy it. Great. And once again, we start at the bridgeheads. We start to number for size. So we have 1, 2, 3, 4. 1, 2, 3, 4. And we have 1. That's a terrible color. And so what we can say is that this is going to be bicyclo 4, 4, 1. Add these together. 4 plus 4 is 8, plus 1 is 9, plus 2 is 11. And if you remember, 11 is un dec, and it's ain for now. And so the question is, well, are we going to, both of these ring sizes are the same, so which one are we going to number? Are we going to number towards the red or towards the green? And we're going to number towards the red because that's going to give us lower locants on our substituents. So I think it's quite clear that this is going to be 2,3 dimethyl bicyclo 441 undecane. Okay. Well, you might be wondering, well, what happens if there was an OH over here? Well, in this case, then we're going to follow the rule of highest priority group, and we're going to say, oh, we're going to number towards the green side because we want to give that higher priority group the lower number if all else is equal. Remember, though, that if it was on the smaller ring size, we don't care because it's on the smaller ring size. Okay. You might also be wondering, well, what happens if it's here, right? What happens if there's like an OH there? What number is that? Well, that number is always what is the last number counted, okay? So we know that the last number counted for the first ring is going to be 4, right? 1, 2, 3, 4. And then the last number counted for the uh, second ring is going to be 8, right? So 1, 2, 3, 4, 5, 6, 7. Oh no, I don't think that's right. No, we can't say that. Basically what it is that I'm trying to get at here is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the last portion is always going to be the last carbons available. So if it was there, then we could say this is undec 11. Well, we want to say undecan 11 ol. Okay. Hopefully that makes sense. Once again, basically remember that the smaller size always gets counted last, even though it might be a higher priority group. And then on top of that, just make sure that you're counting the correct carbon. So, this carbon is going to be coming last, so we want to give it 11. Okay. And then for the last portion or the last problem that I just wanted to show you was this guy. So I'm only going to try once to copy it. Otherwise, I'm just going to redraw it. Perfect. And what we notice going on is that we have, here's our bridgehead. All right. How do I know this is a bridgehead? Well, it's because all 3 portions of the molecule touch this one carbon. Okay. And so I see I have 1, 2, 3. 1 carbon, then I get to the other bridgehead. So that's the end of that chain. And then I have this 1, 2 in the middle. So what do we have going on here? Well, we have bicyclo 3, 2, 1. Okay. Why isn't it 3, 1, 2? Well, it doesn't matter if I draw it this way because remember that they always get numbered in decreasing order, right? So 2 is greater than 1. Likewise, this is going to be 3 plus 2 is 5, plus 1 is 6, plus 2 is 8. So this is going to be octane. And then remember that as well, we're going to be numbering towards the bigger side. So what this means is that for our bridgeheads here, that 1, 2, let me put this in the same colors. 1, 2, 3, 4, 5. Then into our next largest ring, 6, 7. And then finally the last chain, which is just 8. Okay. So this is going to be 8, 8 dimethyl. Okay. So what this one is showing you is that it doesn't matter if this ring size is bigger, right? If this one appears that it's written in the same way the other ones, it doesn't matter. We go by the sizes, right? So if this one is bigger, it gets counted next. All right. So don't get tripped up and try to put this on a lower carbon when it's the highest part of the molecule, I guess is what I'm trying to say. All right. What happens, I hear you say, if, there was a double bond here? Well, then this would just be oct 6-ene, right? And remember that we always name double bonds from where they start, not where they go. So this is going to be 6-ene. Well, the question always comes up, well, what happens if we have a double bond here? And the answer to that is it's not possible. Okay. Check how many bonds are there. 1, 2, 3, 4, and then don't forget that little hidden hydrogen there. 5. Okay. This is not a possible bond. All right. Are there instances where you can have the double bond there? Yeah, it is. And in which case, if that hydrogen wasn't there and we did have the double bond, then what we essentially would have to do is we'd have to count through the bond. Okay. So what am I trying to say is that if we did have that double bond, because I'm labeling one there, I have to follow through. So I'm locking the orientation of the molecule. Okay. And in that case, we would just finish up numbering the way that we expect. Okay. So this would be 3, 4, 5, 6, and then we would call that 7 and 8. All right. Not as pretty, but needs must for when we have these more complicated. Your teacher will most likely not give this to you because it's a little bit more complicated and these are very, very unstable. And the reason is, in case if you're curious, maybe you are, maybe you aren't, is if we look at what this molecule looks like in 3D, essentially what it is that if we try to put the double bond there, we're getting a very, very, very bad angle on this bridgehead. Okay. And that angle is going to totally, totally destabilize what's going on. Not to mention that the functional groups that would be here would be incredibly, incredibly unstable. So very, very, very bad position, very hard to get the molecule to do that, which is why the A, they don't really exist, and B, your teacher is most likely not going to give it to you. Same thing about, double bonds on the bridge and, all those other things students love to come up with. Very hard. It's easier to do it when the bridgehead is 0, but, your teacher will decide how much they want to go into it. But hopefully this makes sense. Hopefully this was helpful. If not, let me know, and I can help some more.